had somebody working on it a little while ago. And like part of the reason you said we're sending millions of tons, that's kind of why this
When
thing
I
is
think
so
in this
massive
image,
as it
Dan, you
is.
can actually see the person working at the bottom of the
What's
ship. And as
going
we
on,
zoom out,
everybody?
you see the full ship, that sort of two-tone silver and black. And then the
How's it going?
sense the scale
We are
across.
live here.
And when I do tours, I like to say Starship is really
Sorry about that.
Starship is really big.
We
You can see there
we definitely had some issues with the stream getting it started, but hopefully we stay up and running here. But welcome. If you're new, make sure to follow us. Let me get this set up, guys.
Alloy of stainless steel, and that's where you see the sort of shiny silver parts are stainless steel.
So we have Elon talking.
The reason for steel over aluminum is that the heat of atmospheric entry and the heat of the rocket engines is enough to easily melt aluminum, but steel is much more resilient against both ascent heating, but especially the re-entry heating. And you don't have to paint it, which is actually very difficult to paint a large object that is going through cryogenic cycles and have the paint stay on. It's quite challenging.
And so we've talked about it. It's massive. It obviously takes a whole lot of energy to make that thing move. And that's where Raptor really starts to come in.
Oh, I love the Raptor engine. It's sick. But I just wanted to say welcome to Today in Space. We are doing a launch hangout here for Starship Flight 10. It's live over here.
You've got to have a means of bringing the rocket back to the launch pad. You've got to have a fully reusable orbital heat shield, and that no one has ever made a fully reusable orbital heat shield. The space shuttle, for example, required 9 months of refurbishment between flights. So the space shuttle heat shield would come back essentially partially broken and would require many months of refurbishment in order to fly again. What we're trying to achieve here with Starship is to have a heat shield that can be flown immediately. So the ship, both the ship and the booster, would be caught by the tower arms, and the booster would be placed immediately back on the launch stand, and the ship's got to orbit Earth at least once, but then could be back potentially in one orbit, but in most cases several orbits. So the ship would come back several hours later, but then be caught by the arms and placed on top of the booster. You could also have multiple ships ready so that a single booster could service.
Steve, I wish they
5 or
took
more
my button
ships,
away.
So that you could be flying.
Scuba, they took my
the
button away.
booster
Can you believe that?
in theory, every hour. This is kind of a profoundly fast speed, obviously, for the largest flying object by far ever made. But it's the reason why we catch the tower, we catch the booster with the tower arms, and the ship also will be caught with the tower arms, because that's the fastest way
Don't lie to me, Steve.
to get the booster and the ship back to flight.
How you doing, man?
If we had instead put landing legs, which we have done before for the ship tests, we actually had landing legs that flipped down, and the ship we've successfully demonstrated landing with legs.
Man.
But if you do that, if we were to do that with the booster and the ship,
The engineering feat
here we'd have to
that makes this possible.
land
It's like
somewhere else with the legs, then lift the
biggest
rocket, stow the
Tinker
legs,
Toys.
transport the rocket back to the pad,
With engines.
which is very unwieldy when you've got
It's a skyscraper.
gigantic thing. Then it would be picked up by these tower arms and placed in the launch mount. That would delay the
views
reusability
are
dramatically,
crazy, people.
and would add a lot of mass with the landing legs. So that's why we catch the rocket with the tower arms, because it's the same tower arms that put the rocket in the launch mount.
You can wait.
Are used to catch the rocket.
Scuba, is that what you're saying?
And that means that we can put
But
the
you just don't
booster
want to?
back in the launch mount in less than an hour after liftoff. In fact, the booster is going to come back very fast. Like, 5 or 6 minutes later, this booster is coming back one way or another, or not coming back. So then you really have propellant fill time, which can be brought down to about 30, 40 minutes, and that means it is theoretically possible to fly
I
the
gotta
booster
say,
again.
Scuba Steve, that's very honorable of you.
I think
Yeah,
the
no,
way
I get it.
think
It's a
about
respect
it's
thing.
the jet drives up to
He
the
didn't
jetway,
want to
the people
shove it
get
in
off, and
Elon's
new people
face,
get on,
and
it
he
leaves.
wanted
You don't want
him to
land
have
the
his
jet
thing, his
on a
Starship
different
thing.
airfield and then tow
I get
over
it.
to the jetway. So it's just
What were you gonna
operationally
call
so
yours?
faster.
Yeah, we've had a lot of success with the booster. 3 for 3 on the catch attempts. When we bring it back, we've reflown one, so awesome. And then, Starship superpowers, the whole thing is reusable. So ship reusability is like what we're working on
Hey, the
right
chat
now.
up.
We've been able to get some really spectacular re-entries on a couple of flights. Hoping to get this one for re-entry
Scuba
on the V2
Steve
ship.
signed an NDA.
But yeah, that fully reusable heat shield, that thing that has just never been done before. That's one of the things we're really looking for that data on.
Yeah, I mean, there are thousands of engineering challenges that remain for both the ship and the booster, but the single, maybe the single biggest one is the reusable orbital heat shield. We are confident in making a fully reusable orbital
is
heat
crazy.
shield, but it will require many flights, many iterations to figure out where the weak points are in the heat shield, where we need to change the design, either strengthening the tile or changing how big the gap is between tiles, changing what's underneath the tile.
That's what you named it, Scuba? That's amazing.
100 different variables that we could tweak with the ship tiles, the heat shield tiles. But the only way to know exactly what we should be adjusting is to fly repeatedly and be able to examine the ship upon landing. And we have successfully brought the ship back through the atmosphere and achieved a soft landing multiple times. So we know that this is possible, but we have in the process shed many heat shield tiles. So we need to be able to do this without shedding heat shield tiles, and do so
Marble would be pretty
repeatedly.
heavy.
And I think what you're seeing now is the Starship. This is CG of it coming in and landing on the tower, much like the booster, but there's some additional challenges there where we need to make sure we don't scrape the tiles off as we slide along the
We
chopstick
can't
arm.
shuck the heat shield.
Don't crush the ship.
Rapid
Yeah,
reusability.
if we shuck the tiles, then that's obviously going to fail the reusability test.
So ships can use the tower to land and catch like the booster
Yes.
here on Earth where towers are available. And for our
Pretty heavy
initial
is the
landings
premise.
on Mars and other planets,
So you
we'll
have
need
the
landing legs
pretty
that
heavy
deploy, much
booster?
like what you're seeing here with Ship
Scuba.
15 when we did our suborbital test to prove out the precision descent landing, which was a successful test. We actually landed two. One was we were able to actually recover it, and you can see it here in the rocket garden if you visit Starbase.
Yeah, so the rocket garden that Bill mentioned, we have
Hi,
actually a
Deborah.
whole bunch of boosters and ships, and we'll
Saw
be
your
adding to them
message.
over time. So you can see an
for being
evolution
here.
of Starship just by driving down the highway.
Yeah. So reusability is key. There's some other technologies we're still looking to prove out. Really big one is going to be the on-orbit refilling.
Very
looking to do
proprietary
that
info.
next year, and that's really what's going to kind of unlock, Starship going everywhere else, going everywhere beyond Earth, and that's something that's again
Non-GMO
never
is
been
important.
done before. Kind of like
It's
that
important for thrust.
reusable orbital heat shield.
That's what
But
I've
it's
heard.
going to be something that's kind of some of the other secret sauce to Starship, where we're going to be able to send hundreds of tons per ship to Mars.
Yeah, I like to
Yeah.
think of it as if we get to orbit with
So
a full
this right
cargo
here.
bay, but we're empty on.
This right here. This orbital refueling process, like that's what this Flight 10 should go according to plan, because Flight 11 is getting us closer to training so that this can happen flawlessly, right? Yeah, see, they already pushed. So Elon just said they were trying to. So this year was the year they said they wanted to do this orbital refueling test, which seemed very fast. Now, if the testing had gone better, if they hadn't lost a few ships and were able to get through this flight profile, then I think they could have been good. Need fuel space, just get enough up there. Yeah. Yeah, no, Scuba Steve says we need to fuel space, just get enough up there. I mean, there's only been the first company that's made something that can like refuel satellites. So if you're being serious, Scuba Steve, yes. It would be great to have a fuel station up in orbit, like, and then you're not, then you can do regular trips just to fuel the station, and then your starships don't need to line up with another starship. So, well, I'm glad, Scuba. I'm glad you're being serious. I'm proud of you. So anyway, sorry, Elon is talking, and you can't hear him.
But with full reusability and propellant transfer, those are the key technologies needed for building a city on Mars.
Mating, yeah.
And I'm confident
Technical
that the SpaceX team, which is incredibly talented, will achieve these goals, and we will be landing ships on Mars in the future and building life on Mars, building greenhouses and
life on Mars, baby.
And life on Mars, and ensuring the long-term survival of life as we know it. And it's important to note here that obviously, we are effectively stewards of life here on Earth. That the other creatures cannot build spacecraft and get to other planets. So if there were to be a cataclysmic event, like a giant meteor that destroyed the dinosaurs, or ultimately the sun will expand to envelop Earth and destroy all life, we know this.
That's worst case, yeah.
This is an undisputed fact. Then if we don't take life to another planet, life will be destroyed. So it's incumbent upon us to ensure that we do bring life to other planets.
No pressure.
Ensure the long-term survival of life as we know it on planet Earth.
And I mean, aside from that, there's so much that Starship unlocks by being able to do these things.
I mean,
like,
Scuba, you saw it. They're
going to
gonna
Mars, but there are other.
Scuba Steve, they're gonna be using those. They're Tesla robots for the first ones on Mars, so that way they can try and train it. Dude, a Starship and the Roadster traveling our solar system together, that'd be pretty sweet.
Like Starlink connects our information, this can connect us more physically.
This live broadcast brought to you by Starlink. No, I am a customer of Starlink. This is my it's not my first time, but it's only my second week with Starlink, and it's been pretty good. We're streaming at 6,000 kilobytes, so 6 megabytes, which is much better than I've been able to do.
Or in half an hour.
But I am not sponsored by them. I just pay them money for the service every month.
Yeah, sign me up for that, please. All right, cool.
Cross the Atlantic in 10 minutes, no problem.
Please, yes, sign me up.
You're going 25 times the speed of sound, so that's 30 times faster than a commercial aircraft.
And it's a whole hell of a lot better view.
Yeah, it's a hell of a view.
Yeah.
My best stream location.
Anything else, guys?
Where is it?
I mean, we could say a lot more.
Yeah.
Maybe we should go check in on the.
So Scuba, do you mean like the one where the streaming is the best, or where we've got the most people? But where's my stream location? Oh, it's weird on X. Okay. Yeah, I mean, YouTube's up. Twitch is up. Twitch has been pretty consistent when we are streaming there. Yeah, but I am definitely concerned. I've got some tree branches getting in the way of like a transition of Starlink satellites. So like when the other one's on the way, it's behind the leaves. So I've got a long-term solution. We're going to do a video about it here on Today in Space podcast. But the first one's going to come out, and then we'll talk about the next step, which is mounting it and getting it up Same thing over there, huh? Oh, yeah, when you did it, the tree branches. Yeah. Oh, yeah. For some reason, the way the constellation has been lately, it just has... There are times during the day where I notice that it is getting worse, and it's always the same amount of time. So that's my best guess. If they're successful with this, then there'll be more Starlink up there, and then that way it won't matter as much. But we'll see what happens. I digress.
Separation and the first ever deterministic flip, which gives us extra performance. The reused booster was flown at a much higher angle of attack to push the envelope on capabilities, which ended up causing some internal structural failure, eventually leading to a rapid unscheduled disassembly at landing burn.
Yeah, ship continued its ascent. We did see pressure drop in its main fuel tank and rise in the nose cone. We just had a camera view. We actually caught the failure on camera in the fuel pressurization system. Ship was able to complete its ascent, though, achieved its planned velocity and second stage engine cutoff.
After that, though, we did run into some issues with attitude
Starship
control, which led us to skipping the payload deploy and Raptor relay demos. Starship eventually re-entered the atmosphere in an off-nominal attitude, and communication was lost approximately 46 minutes into the flight test during entry, but of course not before one heck of a light show.
Yeah. That booster RUD was caused by higher than predicted forces on its structure, specifically that internal fuel transport.
For those of you who are like, he just said RUD, what does that mean? It's rapidly unscheduled disassembly. So it's their fancy fun way of saying it blew up. And ended up in pieces very quickly.
On the ship side, we redesigned the part of the fuel pressurization system that failed on Flight 9, put it through a more rigorous campaign, and after subjecting it to flight-like stresses, it did successfully run for more than 10 times the expected.
Let me see here. All right. So they also changed on Starship these top flaps here. So on this version, this is like, early days, but these are now more leeward, so they're more towards the front. And you could see that those are the areas where the heat concentrations were happening, where the tiles were not holding up in the really extreme environments. So yeah, a lot of changes.
The process of loading all of its cryogenic propellant to do a 6-engine static fire when we had a sudden energetic event that resulted in the complete loss of the Starship, and we damaged the immediate area surrounding the stand out there at Massey's.
The most likely root cause was identified as undetectable or under-screen damage to a composite overwrapped pressure vessel, or COPV, in Starship's payload bay section. To address this probable cause, we're operating the COPVs on Starship at a lower pressure and also implemented additional proofs and inspection methods.
Meanwhile, though, keep our launch schedule up.
So let's talk about that. The composite that they're talking about, right? So composites used in structural applications, they're, you really have to understand your process, and you need to make sure you have a way to mitigate voids, right? In a lot of different ways, people are using, vacuum transfer resin molding for composite. They'll lay up the composite, and then they'll pull a vacuum, and they'll pull the all the air out of it, and then they'll have the vacuum pull in all the resin so that you ideally make this, perfect composite. Then there's just the composite layup, where you're just using the wet resin and you're actually stacking it up. There's a bunch of different ways you can make composites, but the challenge with them is not only are they expensive to make, but then a tiny micro fault, failure, crack, void that's in that could mean the end of that, and it'll fail catastrophically, which is what ended up happening at that point. Some minor thing, whether before it got there on the pad or through the various static fire testings that they were doing, there could have been a lot of different areas. How it was transferred, how it was shifted, transferred, like moved around. Like if the crane that was lifting up Starship, or they had to make a quick stop. Like if that shake or the movement of that was interrupted, then you're in trouble, and then you don't even know there's a problem. Oh my God, they're showing off the Tesla bot.
From in space and during atmospheric reentry, all thanks to Starlink. And speaking of Starlink, that's actually how we're coming to you live from the diner, relying on one of those many reliable connections that Starlink is able to put down across the Earth and in low Earth orbit. So for a little bit more information on the immediate future of the Starlink constellation, let's head on over to Hawthorne, where my colleague Tyler Lionquist is standing by. Tyler, how's it going there? And are you ready to see a rocket launch today?
We are definitely ready for a Starship launch here in Hawthorne. Hi everyone, my name is Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. Starlink is SpaceX's low Earth orbit high-speed internet that's bringing connectivity to places where you least expect it, including in space. For today's mission, Starship is outfitted with 4 Starlink terminals, allowing us to get live views of ship while in orbit and all the way down to splashdown in the Indian Ocean. Starlink satellites are built in Redmond, Washington, and that's also where we monitor the health of our entire constellation. So let's take a quick look for more on Redmond.
What a nerd. I love it.
What a lot of people might not realize when they think about the scale that we're operating is that actually 2/3 of the operational satellites in orbit are Starlink satellites. And then all of those Starlink satellites came from right here in Redmond. We've currently got a constellation of over 8,000 satellites that are flying around in orbit. So they're working together to fill out the whole surface of the Earth, make sure everywhere can have service. So we have these laser links that are connected between the satellites, so each satellite can pass data from one to the other. That is what allows us to have these hundreds of gigabit links between satellites, and that's what allows us to connect every corner of the Earth to high quality, high speed, low latency internet.
Yeah, dude, even locally, like I've been getting like 300 to 400 megabytes every day.
The technology that's in there and that's in your antenna is very similar to the antenna that's on the satellite. We use what are called phased array antennas, which is a fancy way of describing an antenna that's made up of many little antennas that work together in order to direct their energy to a specific spot on the ground without a motor.
Pretty crazy.
Generally, satellite manufacturing is a very slow process. It takes people weeks or months to build a satellite. At SpaceX, we iterate very fast, and we have learned how to build satellites at the 70 sats a week rate. As we have focused a lot on production rate, we have not forgotten about our satellite reliability, which is critical to our mission.
If you look at the whole world and you ask, where is the satellite industry? It's right here in the USA, in Redmond, where the vast majority of satellites being built are being built right here. Starlink is a truly game-changing technology, and it's all supported by the global satellite constellation from this space here in Redmond. And we're really just getting started at the very beginning of what we want to do with Starlink.
I mean, look, you gotta hand it to them. You know what I mean? You gotta hand it to them. That is a company spun up from another company, from SpaceX. It's helping them create a service that they can launch and deploy into space themselves, and then their new spacecraft, like Starship, have the terminals on there, so then you could just connect to this global satellite network. Live streams, data. It's insane. Then they're doing this Pez dispenser thing, which didn't work last time, I guess from the pressure of the methane leak, from what I understood. But the efficiency of this, right? This is a pure engineer solution, right? Like, this is crazy. It just has good space sense, right? You're trying to make the most compact thing to deploy as many things as possible with every flight up to space with your available payload. They have an insane payload. And Starlink is essentially funding this whole project for Starship. So, you know, even if stuff at NASA goes belly up, there's a really good chance that SpaceX could really be the last bastion, or one of the last bastions for, what happens with the space industry. Something we'll talk about on the podcast, but certainly fascinating times.
Meanwhile, prop load is still ongoing. We started loading prop at about very fast.
Sorry, folks.
Ones are going to go without humans. They're just going to put minimally viable landers on the surface, land right on the skirt, no legs. This will just help prove we can actually get to Mars, focus on learning just as much as humanly possible, demonstrating what's needed for Mars transit and the ultimate landing.
Crazy next step.
Then, during our next window from 2028 to 2029, we'll attempt to land the initial infrastructure and start delivering more equipment while evaluating available resources on the planet. And we'll also have Optimus on board for the ride, designed to do the initial heavy lifting.
Beyond that, by 2030, 2031, as these windows open up roughly every 26 months, we'll continue to increase the amount of payload we're sending on each ship as we're building out more infrastructure, mining resources, generating propellant for ships to come back from Mars. By 2033,
what a brilliant way to vertically integrate your various companies to then be able to use it for something else, right? Like, that's wild. Like, it really is wild that they are able to just like, oh, we're also working on this robot at our car company that's embedded with our AI that we have also at our online social media company. And the boring technology and, underground tunnels and we can just mix and match them and use them whenever we want to. Crazy.
We're going to need a whole lot of people that are going to come and help us build this. So it makes it really fun for me to come to work. I know you build these things.
100%.
It's got to be fun for you.
Yep, very exciting.
All right.
Looks like we're about 5 minutes from Starship's 10th flight test. Range is still looking good. Still haven't.
So, yeah, that's one of the cool things about SpaceX employees, right? The people that are doing this broadcast, they are full-time employees. They have other jobs. The broadcast piece is not just like they're a broadcast person. Like that's not how this works. You have to be having. I would assume you would have to be a stellar employee to even be able to have that opportunity. So something interesting if like you're a media person and you're like, I'd love to work at SpaceX. If you want to do the broadcast, believe me, I have definitely thought about it and looked into it because that's one of the futures I see myself doing is space broadcast. I mean, we're doing it now, right? But yeah, you got to be a full-time employee, which I think is pretty cool. I think it's pretty cool.
We're just really preparing the vehicle to get ready to go.
What do you think?
I'm not sure if we passed it already, but we do a final thrust vector control check out the TVC. We'll wiggle the engines that we use to actually steer the rocket itself.
That's how it's official.
Everybody's favorite topic, if we need to hold. That hold would come at T-minus 40 seconds. We can hold if we're still waiting for the weather to clear, which is our big item
my God,
today,
almost 1 million
or
views
if any
on
other
X.
last-minute issues pop up. We'll only hold there if we have an issue. Still waiting to hear confirmation that the weather has cleared. That's the only thing it looks like would hold us today. Here's the business end of a Super Heavy.
Oh boy, look at that,
once
baby.
we pass that T-minus 40-second mark that Dan was talking about, a number of events are going to occur in rapid succession. The ground spin and ignition systems come up to flight pressure, and ship will switch over to internal power. After that, the quick disconnect arm lockout is removed in preparation for retraction, which occurs shortly after T0. And once we pass that T-minus 40-second mark, we do still have the ability to then recycle the count under certain conditions back to T-minus 40 seconds and hold there there to assess what happened, and if we can proceed again back to liftoff.
Yeah, we hope that doesn't happen, but it has previously. I promise not to psych anybody this time. We do have some kind of points of no return. Once the water starts flowing out of that flame deflector under the launch mount, that happens just a little after T-minus 10 seconds. That triggers, and then we hit a hold. That would be a scrub for the day. We have to refill the water tanks, can't turn it off, got to refill prop, all that stuff. So